The angle sum theorem states that for any triangle, the three angles will always add to 180 degrees. So for example, with this triangle shown, I have all three angles labeled, so I can say that 42 plus 53 plus x equals 180, and then just solve for x. In this example, we have two triangles that are sort of joined together at one of their angles. The triangle on the bottom, we only know one angle for, so we can't at the moment find the other angles. But the triangle on the top, we know two of the angles, so we can find the third. So we can say that 28 plus 82 plus the measure of angle 1 equals 180. So angle 1 is 70 degrees. And it is a vertical angle with angle 2, so they're congruent to each other. So angle 2 is also 70 degrees. Well, now we can find the third angle in the bottom triangle. We can say that 70 plus 68 plus the measure of angle 3 equals 180. So the measure of angle 3 equals 42. The third angle theorem says that if we have two triangles that have two angles in common, such as the two triangles that are shown in this picture, let's say that we know that these angles are congruent. And in this particular case, there's some vertical angles that are also congruent. Now, the triangles don't have to be touching for this theorem to apply, but if we have two triangles with two angles in common, then the third angle theorem says that the third angle must also be congruent between these two triangles. And that's simply because if we know two angles in a triangle, then we know the third. If we have a triangle like this one, and we extend one of the sides, so we go past the triangle, then we get an angle that's outside of the triangle, and that angle is called an exterior angle. So it can be any side that we extend on a triangle. So all of these would be exterior angles. Now there's always going to be one angle inside of the triangle that is adjacent to the exterior angle. So for this one, the adjacent angle would be there, and for the next triangle, this would be the adjacent angle, and over here, this would be the adjacent angle. The other two angles are not touching the exterior angle, and they're called the remote interior angles. So these two are the remote interior angles, and they're called remote interior angles because remote means farthest away, or far away, and they're the two angles farthest away from the exterior angle, and they're inside the triangle, so they're interior angles. For the second triangle, my remote interior angles would be these ones. They're just the two angles that are not right next to the exterior angle. The exterior angle theorem says that the measure of the exterior angle will be equal to the measure of each remote interior angle added together. So my exterior angle here would be equal to these two angles added together. So let's just do a quick, easy example before going on to the more complicated problem that follows. So let's say that we have a triangle, and I've drawn an exterior angle, and let's say this angle here is 40 degrees. Let's make that stand out a little bit better. And that this angle at the top is 30 degrees. And we want to find the measure of the exterior angle. The exterior angle in this case would be just equal to the sum of the remote interior angles, which are 40 and 30. So the exterior angle would be equal to 70 degrees. Now you might ask, why wouldn't I just find this angle here and then subtract from 180 since these form a linear pair? And that'll work in this case, but you won't always be able to do that. And let me show you an example. In a problem like this, we can't find the actual measures of the angles inside of the triangle using the 180 degree thing. There's no way we can just find this angle right now. So we're going to have to rely on the exterior angle theorem and just say that the exterior angle is equal to the two remote interior angles added together. So that's a case where you have to use the theorem I just talked about. So this example, there are several problems in this one picture. I know a few angles here, and I have angles 1 through 5 that I want to find. And there are some exterior angles here, among other things. So if I start with angle 1 is exterior to this triangle here. And we know the remote interior angles. They are 50 and 78. So angle 1 will be 128 degrees because I just add those together. Now angle 1 and angle 2 are a linear pair, so I can subtract 128 from 180 to find out what angle 2 is. And so that will give me 52 degrees. Now, for angle 3, that is an angle in the middle triangle, and the 120 degrees is actually an exterior angle to that, and angle 2 and angle 3 are remote interior angles. So what I could do is say that the exterior angle is equal to angle 2, which is 52, plus the measure of angle 3, and solve it that way. Now, angle 4 is a linear pair with the 120 degree angle, so they should add to 180. So angle 4 is 60 degrees. Now, here's the one I'm just throwing in to make sure everybody remembers the stuff from chapter 3. There are two parallel lines in this picture. There's this line and this one. I've got the little arrowheads on there to mark them parallel. And then we have a transversal going through both of them. And so angle 5 actually corresponds to angle 1. They're corresponding angles, and since the lines are parallel, that means that they are congruent to each other. So angle 5 will also be 128 degrees. The word at the top of the slide is pronounced corollary, and that just is a word for a theorem that's related to another theorem. And the two theorems on this slide are related to the angle sum theorem, the one that says that the three angles in a triangle add to 180. So the first one says that the acute angles of a right triangle are complementary, meaning they add to 90. So in a right triangle, I have one right angle, and then the other two angles are the acute angles. Well, since this triangle's angles add to 180, and I've already got 90 degrees of that taken care of in the right angle, the other two angles must make up the remaining 90 degrees. Therefore, they must be complementary. Now, the other theorem says that there can be only one right or obtuse angle in a triangle. And this is because if I try to draw a triangle with two right angles, well, first of all, you can see that the sides of the triangle will never meet to complete the triangle. It'll never be a closed figure with only three sides. And also because the two 90-degree angles add up to 180 degrees, and I don't have room in the equation now for a third angle. I already have the amount of degrees that I need for the whole triangle. And if I try to do the same thing with two obtuse angles, I'm in an even worse situation. So with the two angles that I have here, those are already going to be above 180, so that won't work either.